Thank you for coming to this session. This is about controlling the camera and 3D navigation in your ArcGIS API for JavaScript app. I'm going to be talking about how to control it, how to both interactively and also programmatically. And this will be quite a short session. I'll try to go over a couple of demos and seeing how you can basically control the 3D camera. So the specification of the view in 3D is not really the same as the one in 2D, where you might have an extent or a center and a scale. Instead, we have a camera. The camera is defined by a position, which is a 3D point, where it's basically where the camera is located, so the viewing position, plus a heading and a tilt angle. And this defines fully where the camera is sitting in 3D space. So the position is basically in the spatial reference of the view, plus it has a z value, which is the elevation of the camera above ground. So one important thing that you should know about the camera on the scene view is that it's a value object. This means that if you would just do view.camera.heading plus equals something, this actually doesn't reflect correctly the change on the view. So you would always have to create a camera and then assign it to the view. So the way you do that, I have an example here. So a basic empty scene. And what I can do is if I play this little snippet here, I basically take a camera, clone it, add 10 degrees to the heading, and then set that camera on the view. So when I do that, you can see that the camera is rotating around the position where it's sitting at. So this is basically what we call a kind of look around kind of camera change. I can do the same with tilt, obviously. I can just do it like this, which changes the tilt of the camera. And I can also do it, for example, for the position. So this will move the camera up. I can move the camera sideways, down, stuff like this. So that's basic camera navigation that you could do with just manipulating the camera directly. Sorry. So I just want to talk briefly about the compatibility with MapView and the 2D way, let's say, of defining where you're looking at the map. And we do try to support most of these things, but I just want to show you how these concepts don't really map one-to-one directly into 3D. So here I have a small city layer that I added to my scene, and this city layer has a certain extent, and let's say that I want to just set the view extent to the full extent of the layer. So in 2D, you would just see that whole city then on your map. So if I do this, so what happens now is that you can see that, okay, so the whole extent is kind of visible, but it's not really completely into view. And the way that we do this is we make sure that if you actually look down like this, let's say more or less the same way as you would look at the 2D map, that this extent of the layer that you set to the view extent kind of completely fits the screen. But that means as soon as if you're tilted like this, obviously we cannot, our view is not defined by an extent, right? So we just try to frame it like this, and this way you can see also here I have a small 2D map that actually uses the same. That's basically a view on the same location, and we synchronize these by checking the extent. So we copy the extent of one to the other, and this way you can see that if I rotate it, the extent that we compute in 3D doesn't actually change, because in 2D you see that this basically stays in the same position. So it's good to be aware of these differences. And for extent, it's still quite reasonable. We try to do a good job. It gets harder actually when you zoom out. Here, the extent really starts to not mean a lot anymore in 3D. You can see that in here, for example, if you look at the minimap, if I rotate like this, it starts also to actually zoom in and out because the way we have to compute the extent. So center and scale is another way in 2D that you would use a lot. And actually these are even more complicated in 3D to get right. So here I made a small application where I wanted to show that, for example, to compute a scale in 3D doesn't make a lot of sense. The way that we try to do this to keep some level of compatibility with 2D is that we compute it at the center of the screen, but obviously the scale that would be here far away in the left corner would actually be very different than the scale here, right? We have like many scales on the screen. And on the other end, it's also actually expensive for us to compute this scale at the center of the screen because we have to intersect all the geometry here. And that's why you see that actually, for example, the center point doesn't always update. We do it kind of whenever we need to. And it's good to know this. So you can also see that the scale, for example, can drastically change when I zoom around here. So you can see that's continuously updating. It's not the same thing as in 2D, right? Also, when you rotate, for example, so suddenly the center of the screen, which is just this point, that's like the view.center that you would get, doesn't always directly update either. For example, now, if I go behind this mountain, only when I release it, we actually recompute this. So these are just things, it's good to be aware of that. They might change a bit in the future, so we might be able to compute this like more often, for example. But just be aware that these concepts, they don't really work so well in 3D. So just to go back to, so you saw how we can manipulate the camera, but it's often not very convenient. So if you want to just, let's say, frame a certain set of graphics, or maybe you want to go to a specific location, like view a certain thing at the location, but you don't know where to position the camera, then we have a method called GoTo. This is the same in 2D and 3D, but especially in 3D, this can be quite helpful. So we have a number of different targets that are supported for the GoTo. You can do a long lat, you can do a camera, geometry, multiple geometries, or multiple graphics. I will show some examples of this. And this can be quite convenient. You can also specify additional things. You can say, okay, I want to view these graphics, but at this approximate scale. Or I want to view these graphics, but I want that the camera is at this position. And then this will calculate for you the appropriate heading and tilt of the camera to do that. It also animates. So if you saw before, I said, like, update the camera. This is just an update of the view, right? There's no animation going on. With GoTo, you will get an animation by default. You can also turn it off. So let's look at how that looks like. So I have a snippet here. Basically, it's going to move the view at a multiple of 30 degrees when I play it. So you can see I display here below the heading that is currently being reported for the camera. And so each time I click, it will increase by 30 degrees, it will animate, etc. I can do the same for the tilt. Just animate it. This case, it will cycle through 15 degrees tilting angles, just like that. And it's important to know that when I changed the heading on the camera, I was actually doing a look around type of movement, right? The camera stayed in the same position, but it was rotating around its own position. Here with GoTo, if I change the heading, it's actually rotating around the center of the view. And we do this because we try to preserve always all the properties of the view that are not affected by this GoTo. So if I want to change only the heading of the view, then I would basically not change the center. So that's the idea behind that. There's some other things we can do. So this is all the basically navigation. I want to talk a bit about what else you can do. And here I want to show you a little bit how you can do continuous rotations, for example, using GoTo. So when I play this snippet, I don't have all the code here because it doesn't fit on the screen, but basically it does a request animation frame, and then each time starts to update the camera, and you can see how it smoothly rotates. There's a couple of things that are important here. Well, first, I do basically this look around, the rotate around. That's this kind of rotation, but if I change this, I can also just rotate around the position. And some other things that are nice, and this code will be online so you can look at it, is as soon as I start navigating, for example, interactively, I stop the animation. We have a property on the view that you can monitor and then pause the animation, and as soon as I release it, it will rotate again. And it also does things like, for example, I can easily rotate around the new center point of the screen after I stop navigating. There's one other thing that I wanted to show, which is that if you want to do this kind of rotation, it's best to preserve like the current scale and center of the view while changing the heading. If you don't do this, we have, because of the way that we have to compute the center and the, let me try to do it like this. So let's say I'm rotating around this point here, around this mountain, and then as I'm doing that, I'm rotating, like, and another mountain comes into view. If I would then just keep on rotating, it will preserve the center that it then has and then starts to rotate around another mountain. So these are kind of things that you will run into and that you have to be kind of mindful about when you start to do navigation in 3D programmatically. So here I call this stable rotation. This just means that whenever I start the animation, I record the center and the scale. I just preserve it, and then each time when I do GoTo, I'll provide these two values, and then it will always just rotate around that point. Some other things that you can do with GoTo, which are quite nice, is, for example, you can go to a set of graphics. So if you would have a feature layer, so here I have a simple feature layer, and I would query certain features of that layer, and then I want to frame them. That's kind of the use case. So what I have here on the left, I construct a new query, and I will try to find all the buildings that have a field value elevation larger than 90. The elevation here is like the building height. So I have a couple of settings here. I don't want to return any geometry because this is multi-patch. The query won't work on multi-patch if you want to try to return geometry, so I have to turn that off. And then I will only, sorry. I will only query geometries within the current view extent. And I want to get the object ID field out. As soon as I do the query, so this is going to the service, it has a promise, I will wait for the result. I will get all the object IDs out, and currently we need to do another query to get actually the graphics. So these are the graphics that come back from the server. I need to know the graphics that we are displaying. So this is something that we will simplify in the future, but for now you'll have to do it like this, which means that I will take the layer view, that is the view of this layer, query the features with a query that just matches the object IDs, and then as soon as I get those, I can do view.goTo graphics. And here I added also, I will show this a bit more, animation option that we added in 4.2, where you can also change a bit the behavior of the animation. So if I play this, it will go to the service, query the graphics, get them back, find the graphics in the view, go to the graphics, and I also show here a feature that is currently not yet in 4.3 available, but it will be available in 4.4, which is highlighting. I will not go too much into it, but you can see how you can create nice user experiences where you say, okay, find me these graphics, highlight them, go to them, etc. So another thing that is useful, where you can use GoTo with graphics, is hitTest. hitTest is the method on the view where you say, okay, find me the object or the graphic that is behind my screen position, X, Y. So what I did here is I made a small example where on double click, this is part of our new eventing system. If you don't know too much about that, you can look at the SDK. I will not go into too much detail here. I will show another small example of it a bit later, but not too much detail. What I get is then basically an XY position, so the cursor, right? And then I do a hit test, which will get me one or more graphics. Currently in 3D, you will at most get one graphic. This might change in the future. So I'll get the graphic out. If there was a graphic under the cursor, again, I create my GoTo target. In this case, I want to go to that graphic at a certain scale. So I just say, the target is this graphic, but I want to view it at this scale, and I want to view it at this heading, which is my current heading plus some number. So it will kind of do like a smooth rotation and zooming in to that object. I will also slow it down a bit to get a bit nicer animation. And so let's try to do this. I will double click maybe on this building. So you can see how that works, right? So if I select this one, sorry, I have to double click. It will do this kind of rotation. It will increase the heading. It will zoom to it at this specific scale. Again, the scale is very approximate. Obviously, it's hard to evaluate this because there's multiple scales. We try to do it at the center of the object. So some of these animation options, I would like to highlight some of them. These are relatively new. We had a lot of feedback, people wanting to control the animations more. So we used to just say, okay, we animate it for you, but you cannot control how long it takes or how fast it feels. And we did quite some improvements there to get you a better consistent animation feel, but also the controllability of that. So I will just first show, these are kind of the default settings. The speed factor here is 1, and I have a kind of easing in, out, easing. So if I go to Montreal, so this is actually a web scene with some slides that I show here. So you can see the kind of animation that you get. So we try to do, from whatever scale to whatever other scale you animate, to always get a kind of consistent visual feedback of that animation. So this is like going from planet scale to city scale. And if I go from within city scale to another building in the same city, you get the same kind of animated feeling, right, in terms of the speed of that animation. And then, of course, I can start to do things like, okay, I speed it up, so I get a much faster animation or a much slower one. I can do other things like change, for example, the easing. So this is the easing in, so it starts slow and then accelerates and then kind of stops the other way around. I think, most of you will know this. These are the default easing of many of the JS libraries. The other thing that we do is that if you do very large-scale transitions from small scales, basically somewhere in the world, to another small scale very far away, we do this kind of transition where you first kind of zoom out to a planet scale or a larger scale and then zoom back in. So this is kind of a slower animation because I set that here, but I can speed it up a bit. So we do this to give you control of these animations. So in your app, if you want a certain user experience, then you can really design this now. And then you can also do some fun stuff. So for example, if I go here to Berlin, you can do custom easing. So you can do your own easing functions if you're not happy with the ones that we provide. Here I implemented kind of a funny one, which is, I will slow this down a bit, which is like this bouncing easing. It's not very useful in this sense, but you can just control, let's say, how you ease over the animated path if you want to. And of course, this worked on all the scales, so I can do stuff like that. I want to briefly talk about keyboard and touch navigation. Touch navigation is new also. We added that very recently. I cannot show it really here because I don't have one of these fancy laptops. But basically, you can use all the normal pinch, zoom, rotate, 2-finger tilt, the default basically touch touch navigation. If you have one of these laptops, try it out. If you try it out on the phone, this is also possible. You will get the same experience. And then there's some keyboard navigation. So these are the things that they are interactive. You don't have to, there's nothing programmatic about it, but it's good sometimes to know about these things. So we have keyboard navigation. I will just say what I'm pressing because I don't have it on the screen. This is arrow keys, which is basically panning around the scene. So arrow up, arrow down, etc. This is pretty useful, but there's some others that are maybe less well known. For example, we have P, which will put you, let's say, perpendicular to the surface. So it's more like a 2D-ish view. So that's pretty useful. We have N, which will put you north. This can often be useful because when you're navigating around the globe like this, we currently don't really preserve the heading for you. You can see here the compass on the top left kind of rotates. If you want to quickly go back to north, you can just press N. There's a couple of other keys that might be useful. We have up and down, for example. This is J and U. So yeah, you can use this. It's sometimes useful, not always, but it's good to know. You can look at the SDK. If you go to this link here, I can show it also later. It will tell you all the keys that are available, but also all the touch navigation that you can do. I have a few other small examples of things that you can do when you start to do your own custom input handling and then doing your own navigation with that. So this is an example where I take the drag event. This will work for any pointer type. So this will work For the mouse, for touch, it's exactly the same way. So you don't need to really think about that too much. Here I want to implement something that I just mentioned before, where if you drag on the screen, I would actually like that the heading doesn't change. So that I always preserve the same heading. If I'm looking north, I should always be looking north. So it should be independent. Now this is kind of hard to do in the way where when we pan, we actually try to preserve the point where you clicked while you're dragging. This is kind of a harder problem if you want to do it correctly while preserving heading. So in this case, I'm not going to do that, but I'm going to just preserve the heading and do like some kind of factor of dragging related to how much I rotate the Earth. So here, basically, I couldn't put the whole snippet again, but basically what you do is when the event starts, you store the current center scale, heading, and tilt, like the whole view state, and then while you're dragging, just depending on like what the change is in my screen position, I will update the center X, which is like just the X in map space, and then I'm gonna scale it by the scale so that I get, like if I'm zoomed out, obviously I need to change it much more than if I'm zoomed in. So if I do this and I start to rotate, you can see that the point is that under the cursor is not preserved, but the heading is. And this is sometimes useful. So if you don't care too much about exactly preserving the point, but just the rotation, then I can do this like this. So now basically I overrode the default navigation of the view with my own handler. So you can see that sorry, I'll do it. Okay. I'll do it like this. Okay, so you can see how the heading is always preserved here. The compass doesn't change. So my last demo that I want to show is a little bit more advanced. It also is actually not using the drag. I changed this last minute to make it a bit nicer using the mouse. Scroll wheel event. So I'll update the slides. I'm sorry for that. So the idea is that what I did is I wanted to do a kind of camera follow along a path type of thing. So I want my navigation to be constricted to something along this path, and my mouse scrolling is gonna like navigate this. This is a bit like how you sometimes have these websites where you scroll with the mouse and then suddenly like all kinds of things fly in and out, and if you go back up and down. So I wanted to show this, and then I'm gonna dig a little bit into the code. So I'm basically scrolling on my trackpad here, and the camera is gonna follow the line. And I just did this by recording in certain positions the camera, and I'm interpolating based on where I am, like how far I scrolled with the mouse. So I can go this up, up, up. And basically by just scrolling, I can kind of have this camera along a trajectory. So now I'm scrolling out. The nice thing about the trackpad on the Mac is that the test is kind of acceleration. So I get kind of this kind of smooth change for free. It's a little bit too accelerated probably, because here you can see how fast it kind of goes up and down. So I want to maybe like 2 or 3 minutes just quickly look at the code for this. Let me try to open this up if I can. Sorry. Actually, I have to find the right frame. Okay. Is this okay to read? Should I make it a bit bigger or? So yeah, all the snippets that I made and that you will also get, they are made in TypeScript. But if you're not comfortable with it, it's not. It doesn't use classes or things like that, so it should be pretty easy to follow. Basically, what I have here in the bottom is just a whole bunch of camera paths. So what I did is I just went in the scene, put the camera at certain locations, and recorded the JSON of the camera. And then I have a number of positions, and then I just say, okay, from this to the next, it should take like two seconds to navigate, or this is kind of relative time. After that, I have this drag handler. So when I do, well, I call it drag, but this is the mouse wheel really. So mouse wheel handler, I go over this a bit fast because I don't have so much time, but I basically take the delta. I just record, like I keep track of the time. And then I have a function that interpolates based on this like number of cameras, the camera at a certain time. And then again, I use just GoTo to go to this camera. The interpolation is pretty straightforward. There's a little bit of code involved just to do the linear interpolation, find the two cameras that I have to interpolate, and then take a fraction. And then it's just linear interpolation of all the variables. So I just do heading, tilt, X, Y, Z position. It's all just interpolated from previous camera to next camera. So if I do this without anything else, it's going to be pretty jerky. So the cameras, they are not really smoothed out in that sense, right? So I will go like on one segment, the camera will look like this, and then on the next, it will look like this, etc. So you get kind of this jerky behavior. If I can fix this kind of by doing a smooth step on the interpolation, which just means I'm gonna take the cameras around this like a small window and then just average them out. So you get kind of a more smooth like curvature on the various variables. It's mostly heading and tilt that are kind of like not smooth, discrete. So yeah, this is a bit. This is what I wanted to show. And if there's any questions, I will be happy to answer them. Does anybody have questions? If not, then thank you. You can also come here, ask questions if you have specific things. Thank you.